Who planted these nails in this wetland soil? Redoximorphic features in soil.
You might have heard of or seen examples of nail-looking features in wetland soils. These are actually a result of iron accumulating at aerobic areas on the rhizosphere. In the rhizosphere, plants pump oxygen through their roots using porous tissue called parenchyma. Iron in its reduced state will then be oxidized in the region into a solid iron oxide. The oxidation of mobile iron creates a concentration gradient, pulling more mobile iron into the rhizosphere to be oxidized due to the aerobic conditions. The rust then remains since the plant is still living and pumping oxygen down.
These nails we found in the wetland are actually an example of a redoximorphic feature in soils. These are due to oxidizing and reducing reactions performed by microbes in the soil that cause concentration gradients and movement of iron and manganese through the soil profile. Examples of these are shown in the pictures on the slide of pore linings, redox depletion, redox concentration, and nodules.
Redoximorphic features are created under a few required conditions. The first condition is that the soils must be waterlogged at some point, bringing on anaerobic conditions. They also must contain warm soil temperatures, which are crucial in the formation of these redox features. The second required condition is that some iron and manganese must be present in either their reduced state or the oxidized state. In the top left corner, you can see in the desert the orange representing iron being present. In the bottom left corner, you can see the mottled black dark spots representing manganese being present. A third condition is that there must be minor aerobic areas within the soil for accumulation of iron and manganese oxides to occur. Such aerobic areas include pore linings from roots and the rhizosphere. The reaction chain for iron and manganese in soils is fueled by biological processes. Certain microorganisms utilize iron and manganese oxides in anaerobic conditions to respire and create ATP, and this releases mobilized forms of these two elements. The mobile iron then moves towards the rhizosphere around the plant roots, and then is oxidized.
There are three common redoximorphic features that exist in soils, the first of which is redox depletions. Redox depletions are characterized by bodies of low chroma appearing as low-intensity colors. In these soils, iron and manganese have been completely stripped out due to prolonged anaerobic conditions causing the mobilization of these metals. The second feature is known as the redox concentrations. Important characteristics of this soil includes masses, pore linings, nodules, and concretions. Redox concentrations typically occur in well-drained soils where oxygen is present. Reduced matrix soils are signified by reduced iron and manganese being present, which changes color when exposed to air. Oxides in this soil have not been completely stripped out, so we can infer it is anaerobic, but there are still small areas, like macropores, where oxygen is present and oxides still remain.
So now that we know more about these redox features, we can use them as indicators of the soil's strength and its other properties. Soils that are found with redox depletions are usually undesirable construction sites due to its decreased strength brought on by the saturated conditions. In these areas, only specialized plant life will be able to grow. This is because root growth is limited due to the low oxygen levels and poor mineral availability. The redox features can also be used to estimate the seasonal water table within a given soil. They also can help approximate the moisture content, which is useful for farmers and construction engineers. Lastly, these features give us the ability to tell the age of the soil and the historical climate of the soil's region.